So good day everyone. Welcome to another video on construction materials and testing. In this video, we will be talking about the determination of setting time of cement. So cements are materials that exhibit characteristic properties of setting and hardening when mixed to a paste with water. So yung property na setting and hardening, uh, kailangan niya ng tubig para mag-react siya na uh, mag-occur yung ganyan na property ng ating cement. So, yung cement paste, yan yung ginagamit natin na binding medium sa ating concrete mix. So, kapag semento lang na walang tubig, so hindi siya magbabind. So, it needs water. So, it exhibits the properties na setting and hardening kapag na-mix na siya with water. So there are two types of cement, so hydraulic cement and non-hydraulic cement. So hydraulic cements have the ability to set and harden underwater, and non-hydraulic cements does not have that ability because it requires air to harden. So some examples of hydraulic cements are hydraulic limes, pozzolan cements, slug cements, natural cements, Portland cements, Portland pozzolan cements, Portland blast furnace slug cements, alumina cements, and expansive cements. Main example of non-hydraulic cement is yung ating lime. So, yan. So, let us talk about non-hydraulic cements. So, yung non-hydraulic cement natin is yung sinabi na nga natin kanina, it is lime. So, lime is one of the oldest known cementing material. It is readily available and rather inexpensive. So, yung lime natin, yan yung pinaka-common na ginagamit nila nung sinaunang panahon na cementing material. So, it is produced by burning limestone in a vertical or rotary kiln at a temperature of 1,800 degrees Fahrenheit. So, that is 980 degrees Celsius kung i-convert natin. Around 980 degrees. So, yung ating limestone or calcium carbonate. So, ito siya. CaO. Sorry. Quick lime to. So, Ca. So, yung ating calcium carbonate. So, kapag na-burn siya sa ating rotary or vertical kiln, it will turn into magiging calcium oxide and carbon dioxide siya. So, itong calcium oxide natin, wait, sorry. Oops. So, yung ating calcium oxide, so yung ating calcium carbonate or lime, it turns into calcium oxide and carbon CO2. So, it turns into calcium oxide and carbon dioxide. So, itong calcium oxide natin, so CaO, wait lang, sorry. Hindi ko sanay masyado itong ano natin. So, itong CaO, it is called calcium oxide and sometimes it is also called as quicklime. So, ito yung quicklime natin. Ito yung ginagamit natin na tawag dito, cementing material. So, ito yung dinadagdagan na lang natin ng tubig. So, kapag dinagdagan natin siya ng tubig, so H2O, it will turn into, wait lang, sorry. So, it will turn into calcium hydroxide. So, kapag dinagdagan natin ng tubig yung ating quicklime or yung ating calcium oxide, it will turn into calcium hydroxide. So, Ca, calcium hydroxide. And it will also generate great amount of heat. So, mag-iinit ito. So, magiging mainit to. So, lagay na lang natin. So, it will also generate some amount of heat. So, yung process na ito, kapag inad mo itong tubig sa ating quicklime, it is called slaking. So, itong uh, product ng slaking or yung pag-add mo ng tubig sa ating quicklime, ang tawag dito, it is called slaked lime or hydrated lime. So, itong hydrated lime natin, wait lang. Oops. So, itong hydrated lime natin, tulad ng sinabi ko kanina, hindi siya hydraulic cement. So, kailangan niya ng air para siya ay mag-harden. So, ito, magseset lang siya kapag na bawasan na yung amount ng kanyang tubig. So, yung H2O is pwedeng i-absorb siya ng ating tawag dito, mga bricks. Kasi nung mga unang panahon yun yung ginagamit natin. Mga bricks or blocks. Kapag na-absorb na niya yung tawag dito, tubig natin, magsisimula ng mag-set yung ating slaked lime or hydrated lime. And then, para mag-harden siya, kailangan niya ng carbon dioxide. So, magre-react siya with carbon dioxide. So, CO2. And then, yung ating quicklime will be turned into CO3 plus H2O. So, babalik siya into a lime. So, magiging ganito ulit siya. So, yan yung process ng paggamit ng lime as a cementing material. So, babalik din siya into a lime kapag nag-harden na siya with carbon dioxide. So, kailangan niya ng air to harden. So, pwede siya mag-set underwater or basta ma-absorb yung water na nasa hydrated lime natin. Pero yung pag-harden niya, kailangan niya ng ito, carbon dioxide. So, it needs air to harden. So, yan yung ating lime. So, next, we have here yung ating hydraulic cement. So, first example ng ating hydraulic cement is yung ating hydraulic lime. So, hydraulic limes are used for browning plaster coats or for stucco and similar uses. So, it is made by burning siliceous or argillaceous limestone whose clinker after calcination contains a sufficient amount of lime silicate to give hydraulic properties to the product. So, hydraulic limes do exhibit hydraulic properties but are not suited for subaqueous construction because they require free access of air during hardening. So, ito, pwede rin siyang tawag dito, mag-set underwater but kailangan pa rin niya ng air to harden. So, yan yung ating hydraulic limes. So, a pozzolan. So, pozzolan cements. A pozzolan, according to ASTM C595 or blended hydraulic cements, it is a siliceous and aluminous material which in itself possesses little or no cementitious value but will, in finely divided form and in the presence of moisture, react chemically with calcium hydroxide at ordinary temperatures to form to form compounds possessing cementitious properties. So hindi siya tawag dito. Hindi siya cement as itself, pero Kailangan niya ng tawag dito. Ito, calcium hydroxide at ordinary temperatures to form compounds possessing cementitious material or properties. So, yung calcium hydroxide natin is yung ating quicklime. So, kailangan niya ng quicklime to have that cementitious properties. So, kapag yung pozzolan lang, wala siyang magiging cementitious property. So, pozzolan cements are produced by direct grinding of volcanic rocks or by calcining and grinding clays, shales, and diatomaceous earth. So, very little use has been found for pozzolan cements in the area of structural concrete kasi itong pozzolan cement natin ay hindi siya ganon ka tawag dito kalakas. So, hindi ganon kataas yung kanyang uh, strength. So, their main use has been where mass is required rather than strength. So, yung gamit niya is hindi masyado sa mga structural uses. So, yun. Yung kapag kailangan mo ng maraming semento pero hindi naman kailangan masyado yung strength, doon nagagamit yung ating pozzolan cements. So next, we have here yung ating slug cements. So slug cements are hydraulic cements consisting mostly of an intimate and uniform blend of granulated blast furnace slag and sorry blend of ano siya blast furnace slag and yung ating hydrated lime. So hindi siya yung pure na blast furnace slag lang. So meron siyang blend ng hydrated lime natin. So, slug cements, at least 60% of the weight comes from the blast furnace slug. And yung, syempre, 40% ng weight ng ating slug cement is, it comes from yung ating hydrated lime. So, the mixture is often not calcined. Slug cements are of limited importance in structural concrete gaya ng pozzolan. Hindi siya ganun lakas. So, it may find it may be found in projects requiring large masses of concrete masonry where weight and bulk are more important than strength. So, hindi siya masyadong nagagamit talaga sa mga tawag dito structural use. So, yan yung ating slug cements. So, next we have here yung ating natural cements. So, a natural cement is defined by ASTM C10 as a hydraulic cement produced by calcining a naturally occurring argillaceous limestone at a temperature below the sintering point and the grinding of a fine powder. After calcination and slaking to remove the free lime, the clinker is ground to a fine powder known as a natural cement with the following average composition. So, ito yung composition ng ating natural cement. So, makikita nyo, ito talaga yung nagagamit na tawag dito. Ito yung pinaka malaki na percentage na makikita sa ating mga semento talaga. Yung ating CEO. So, yan. Wait lang. So, yan yung ating composition ng ating natural cement. So, calcium oxide yung pinakamaraming component niya. So, ayan. Next is yung Portland cement. So, ito yung pinaka-common na ginagamit natin sa ating construction here in the Philippines. So, Portland cement is defined according to ASTM C150 as a Hydraulic cement produced by pulverizing clinker consisting essentially of hydraulic calcium silicates, usually containing one or more of the forms of calcium sulfate as an interground addition. The approximate proportions for Portland cement are as follows. So yung lime natin, calcium oxide is 60 to 65%, silica 20 to 25%, and for iron and iron oxide and alumina is 7 to 12%. So, itong Portland cement natin, ito yung pinaka-common. It is used in structural concrete. So, sample is mga walls, floors, bridges, tunnels, and mga subways natin. And it is also used in masonry. So, for foundations, footings, dams, retaining walls, and pavements. So, yan yung gamit ng ating Portland cement. So, it is one of the most widely used construction materials and it is the most important hydraulic cement. So, yan talaga yung pinaka ginagamit natin sa ating construction. So, yan yung kapag bumili ka ng semento, yan usually yung binibili mo. Yan yung usually bibigay ng nagtitinda ng semento. So, it is used in concrete, mortar, plaster, stucco, and grout. It is used in all types of structural concrete, whether reinforced or not. And it is also used in all types of masonry. So, yan yung ating Portland cement. So, yan. Meron tayong tawag dito, types of Portland cement. So, type 1, normal. So, it is used for when the special properties specified for any other type is not required. So, makikita natin yung mga special properties ng mga susunod. So, kapag hindi required yung mga properties ng mga other types, so ito yung ginagamit. So, meron tayong type 1, meron din tayong type 1A. So, hindi ko na in-include dito. Type 1A is ang pinagkaiba lang sa normal na type 1 is meron siyang air entraining property. So, kapag kailangan na air entrainment na di naman kailangan yung mga ibang property ng type 2, type 3, type 4, and type 5 na cement, pwede yung type 1A yung gamitin natin. Next type is yung type 2. It is for general use, more especially when moderate sulfate resistance or moderate heat of hydration is desired. So, meron din tayong air entraining na type 2. So, type 2A yung air entraining natin. So, kapag air entraining na normal, type 1A. Meron din tayong type 2A. Kapag air entraining na moderate na Portland cement. Kapag type 3, so type 3 is high early strength. So, yung high early strength is kapag nag-harden na siya, usually meron siyang strength na more than its service strength. Na mas mataas yung strength niya kapag bagong harden pa lang siya. Kasi kapag kailangan mo ng strength early on in its lifespan, so ito yung gagamitin mo na cement. So, meron din tayong air entraining dito. So, type 3A. So, air entraining na high early strength cement. Next, we have here yung type 4 cement. It is low heat cement. So, it is used when a low heat of hydration is desired. So, kapag di mo kailangan ng tawag dito, kapag kailangan mo na i-control yung heat ng hydration kasi talagang kapag nag-hydration process yung ating semento talagang umiinit yan. So, mataas yung temperature niyan kapag during hydration process. So, kapag gusto mo na hindi siya masyadong mainit, kailangan mo ng low heat na cement or type 4. For type 5, sulfate resisting cement. So, yan nga, it has a sulfate resistance. It is used when sulfate resistance is desired. So, itong dalawa, wala siyang air entraining properties. So, itong type 1 to type 3 lang meron air entraining na other type ng cement. So, di ko na sinulat kasi ang pagkaiba lang nila is merong air entraining. Same lang yung property ng normal tsaka type 1A. So, ayan yung ating types of Portland cement. So, next we have here yung compressive strength ng ating mga Portland cement. So, yung percentage ng kanilang compressive strength at day 1 and day 3, day 7, and 28 days age and 3 months of age ng ating Portland cement. So, for type 1, day 1 up to tuloy-tuloy na throughout its life is it will gain 100% of the strength of the concrete. So, type 2, at day 1, it will gain only 75% of its strength. And at 28 days, it will have almost 100% of its strength. So, yung high early strength natin, type 3, at the first day, it will gain 190% of its tawag dito, strength. And at 28 days, 110%. And after 3 months, balik na siya sa yan na yung talagang magiging strength niya throughout its life. And so on. So ayan yung mga strength niya. Every type of cement. So, ito, makikita natin. So, type 1, it is used where there is no severe climate changes or severe exposure to sulfate attack from water or soil. Its uses include reinforced concrete buildings, pavements, sidewalks, bridges, railings, tanks, reservoirs, floors, curbs, culverts, and retaining walls. So, for type 2, pinaka nagagamit kasi sa atin dito is usually itong type 2. Ito yung usual na ginagamit natin dito. So, type 2, it is used in structures of considerable mass such as abutments and piers and retaining walls. It's used also minimizes temperature rise when concrete is placed in warm weather. So, usually, type 2 yung nagagamit. Type 3, it is used when structure must be put to service as quickly as possible. So, kapag kailangan magamit agad yung structure natin, gumagamit tayo ng high early strength na cement. So, type 3. So, type 4, it is intended for mass structures such as large gravity dams where the temperature rise on continuous pour is great. If the temperature were not minimized, large cracks or flaws would appear. So, kailangan, ito yung low heat na cement natin, type 4. So, kailangan sa mga malalaking buhos, yung temperature rise is dapat controlled siya. Kasi kapag masyadong mataas yung temperature, mas madaling mag-evaporate yung ating tubig. Possible na mag-form ng cracks yung ating tawag dito, structure. So, yan yung gamit ng type 4. For type 5, it is used when concrete is to be exposed to severe sulfate action by soil or water. So, yan naman yung gamit ng ating type 5 na cement. So, ito yung mga percentages ng kanilang compressive strength based on the age of the cement. So, after siya na mag-harden. So, next, we have here the properties of Portland cement. So, first, we have here fineness. So, it affects the rate of hydration, the greater the cement fineness, the greater the rate of hydration, and hence the greater strength development during the first 7 days. It is measured by the Wagner turbidimeter or the plain air permeability apparatus. So ito, it affects the rate of hydration. And next, we have here na property ng ating Portland cement. So, soundness. It is a measure of the potential expansion of the several constituent parts of the ability to retain its volume after setting. So, possible kasi na mag-shrink yung ating volume ng ating cement after setting. So, soundness, it is the ability of the cement to retain its volume after setting. So, time of setting. So, ito yung pagpo-focusan natin dito. So, time of setting, it is used to determine if a cement paste remains plastic long enough to permit normal placing of the concrete. It is measured using Gillmore or Vicat apparatus. So, yung time setting, meron tayong dalawang time setting dito. So, initial, wait lang. Meron tayong initial setting time and final setting time. So, ang initial setting time, ito yung time na yung concrete natin is plastic pa siya. So, pwede mo siyang i-place sa final place niya. So, pwedeng ma-mold pa siya sa final place niya. And then, itong final setting time naman is, ito yung time na mag-start na siyang mag-harden. Mag-harden na yung concrete. Itong initial setting time, dapat ma-place mo na siya yung concrete mo sa mold or sa formworks, sa forma na paglalagyan niya bago itong initial setting time. Kasi kapag tawag dito, nilalagay mo pa lang siya after nitong initial setting time, possible na magkaroon ng loss of strength yung concrete mix mo. So, ito naman, mag-start na siya mag-harden dito sa final setting time, yung concrete. So, ito, pinaka-plastic na time pa rin niya, initial setting time bago sa time na ito. So, usually, importante ito kapag medyo malayo yung panggagalingan ng tawag dito, mixer. So, kapag medyo malayo siya sa site mo, so, dapat alam mo yung setting time ng iyong ginagamit na semento or para mas safe, lagyan mo ng retardant para hindi siya mag-set agad. Para kapag ma-traffic man sa daan or is okay pa rin siya na maibukos. So, ito yung importance ng setting time. So, next, we have here yung compressive strength. So, na-discuss naman natin na ito sa concrete. So, compressive strength, it is used to give an indication of the strength developing characteristics of the Portland cement. Next, we have here the heat of hydration. It is the heat generated when cement and water react. So, heat of hydration. So, importante ito kapag large structures gaya ng mga dams na malalaking buhos yung tawag dito nangyayari kasi kailangan kontrolado yung heat sa mga ganong buhos. Next, we have here the loss of ignition. It is the indication of prehydration and carbonation which may be caused by prolonged storage. So, loss of ignition, yung kapag medyo matagal siya na nakastore, possible na may mga mamuong mga clumps ng cement. So, yan yung loss of ignition. And then, we have here the specific gravity of the cement. So, usually, yung specific gravity ng cement is about 3.15. So, ayan yung mga properties ng ating Portland cement. Okay, so next we have here Portland Blast Furnace Slug Cement. So, Portland Blast Furnace Slug Cement, according to ASTM C595 blended hydraulic cements, it is a hydraulic cement consisting of an intimate and uniform blend of Portland cement and fine granulated blast furnace slag, produced either by intergrinding the Portland cement clinker and the granulated blast furnace slag, or by blending Portland cement and finely ground granulated blast furnace slag, in which the slag constituent is between 25 and 70% of the weight of the Portland blast furnace slag cement. So, yung Portland blast furnace slag cement daw is uh, 25 to 70% of its total weight comes from the uh, tawag dito, blast furnace slag. So, the rest will be coming from the Portland cement. So, ayun yung ating Portland blast furnace slag cement. Next, we have here the alumina cement. So, alumina cement has a high alumina content because it consists primarily of calcium aluminates. So, alumina cements have several outstanding properties such as early high strength. So, yung strength niya usually magse-set siya and magha-harden siya to its full strength at 48 hours compared sa normal na semento which takes 28 days para mag-set and harden. So, para makuha niya yung strength niya na full. So, yun usually is Portland cement compared sa Portland cement 28 days kasi sa Portland. So, alumina cement, it takes 48 hours para mag-set, mag-harden, and makuha niya yung kanyang full strength. So, yun yung alumina cement. It has excellent refractoriness and good resistance against chemical attacks. So, alumina cements were used where high early strength is required and moderate temperature are to be maintained. So, kapag kailangan ng high early strength, tsaka kailangan ma-control yung temperature niya, so okay na gamitin itong alumina cements. Next, we have here expansive cements. So, expansive cement is a hydraulic cement containing a constituent that during the process of hydration, setting or hardening undergoes an expansion but remains sound and eventually develops into satisfactory strength. So, gaya ng sinabi natin kanina na may tendency na mag-shrink yung semento natin. Kapag importante na hindi mag-shrink yung semento, expansive cement yung kailangan gamitin para siya yung tawag dito, ma-counter niya yung pag-shrink ng semento mo. So, yun yung gamit ng ating expansive cement. So, we have here other special Portland cements. So, first we have here white Portland cement. So, it is used for decorative display. It has low iron and manganese compared to normal Portland cement. Kaya puti yung kanyang kulay. So, mababa yung iron and manganese content niya. Next, we have here colored cements, also used for decorative display. So, it is made by intergrinding chemically inert pigments such as metallic oxide in the amount of 3 to 10% to Portland cement. So, decorative yung gamit nito. And then, next we have here oil well cements. So, these are low setting cements which are used to seal deep wells. Next, we have regulated cements. So these are rapid setting and hardening cements. They are used in manufacture of blocks, pipes, pre-stressed and precast concrete. In strength, they are comparable to Portland cement types 1, 2, and 3. Next here, we have yung ating waterproof cement. So it is a Portland cement interground with a water repellent material. So it is used to reduce the water permeability of the concrete. So next we have hydrophobic cement. So almost magkapareho lang sila ng waterproof cement. So ang pagkaiba lang yung waterproof is ma-waterproof yung uh, mix mo. Ito namang hydrophobic cement, ang tulong lang ng waterproofing sa semento is to prolong the life of the cement during storage or while being transported long distances. So, para hindi mag-clump yung semento mo kapag kailangan siyang i-store ng medyo matagal or kailangan siyang i-transport ng tawag nito, malayong lugar. Next, we have antibacterial cement. So it is a Portland cement interground with an antibacterial agent with the intention of reducing harmful microorganisms. It is used in food processing plants to minimize deterioration caused by fermentation. So lastly, we have barium and strontium cements. So these are Portland cements in which their calcium oxide is replaced completely or in part by barium oxide or strontium oxide. So their purpose is to act as a concrete shield in which the barium and strontium absorbs X-rays and gamma rays. So mga X-ray rooms ganun. So it will absorb yung mga ganong rays. So yan. Next we have here ASTM specifications. So for the testing of cements. First, we have here yung ating normal consistency of cement. So ASTM C187 yung ating specification. So standard test method for amount of water required for normal consistency of hydraulic cement paste. The minimum quantity of water required for cement to form uniform paste that will provide sufficient viscosity which allows the Vicat plunger to penetrate 5 to 7 millimeter point from the bottom and 33 to 35 millimeter from the top of the Vicat cement ball. So yung Vicat cement ball natin is it has a height of 40 millimeter. So according to standard condition of temperature and humidity is known as cement normal or standard consistency. So, ano yung importance nitong normal consistency? So, kapag less than the normal or standard consistency, yung ilagay na amount of moisture or water, it would not initiate the chemical reaction between water and cement, resulting in reduction of strength of cement. So, maraming semento na hindi magre-react sa tubig kasi konti nga lang yung nilagay mong tubig. So, excess of water naman, it can also result in reduction of strength. So, kapag sobrang maliit or sobrang marami, same lang yung possible na mangyayari. It can cause a reduction of strength of the cement. So, yan yung dahilan kung bakit importante na kunin natin yung normal consistency of cement para alam natin yung water cement ratio na gagamitin natin na very optimal. So, para makuha yung pinakamalakas na water cement ratio natin. So, yun yung normal consistency of cement. So, panoorin natin itong video. So, para kung paano i-test itong normal consistency of cement.
In this video, we will cover the normal consistency of hydraulic cement experiment. In other words, we will measure the amount of water which is needed for the cement to react completely with water. To perform this experiment, you need the following: a mixer, a Vicat apparatus, a conical ring, a balance, a 650 gram of hydraulic cement, and water. For start, measure a randomly assumed amount of water. 170 gram of water is a good initial assumption. After that, put the cement in the mixing bowl. Then add the water to the cement and wait for 30 seconds, allowing the cement to absorb the water. Fix the bowl in its place and run the mixer on the slowest speed for 30 seconds. Stop the mixer for 15 seconds. Again, run the mixer on the medium speed for 1 minute. Turn off the mixer. Then quickly start to form a ball from the cement paste with the gloved hands. After that, toss the ball between your hands for 6 times.
So, ayan yung i-form. Dapat ball yung kailangan na ma-form. Tapos yun yung ilalagay dito. Hindi yung ipupunuin nyo itong ball. So, dapat mag-form kayo ng ball na itotos nyo 6 times. Yan.
Place the ball in the conical ring. Using a straight edge, remove all the excess paste on top of the ring. Place the paste under the 10 mm Vicat rod. Adjust the rod until it becomes in contact with the paste surface. Then, set the indicator on 0. Release the rod. The rod will penetrate the paste. The normal consistency is obtained when the penetration is equal to 10 mm after 30 seconds of forming the ball paste. So, you have to repeat.
Wait lang. So, dito. So, ang sabi dito is dapat mag-penetrate siya 5 to 7 mm from the bottom. So, ito siya. So, mula dito sa bottom nung mold natin, so dapat hanggang around dito. So, itong depth na to is 5 to 7 mm. So, yan, 5 to 7. Sorry. 5 to 7 mm dapat, or kung titingnan mo siya mula sa taas is 33 to 35 mm from the top of the mula dito sa top. So 33 to 35 mm dapat yung penetration niya. So kapag titingnan mo naman mula sa baba, 5 to 7 mm. So yan yung normal consistency of cement.
The paste. The normal consistency is obtained when the penetration is equal to 10 mm after 30 seconds of forming the ball paste. So, you have to repeat.
So next we have here the setting time of cement. So astm C191. So standard test method for setting time of cement. So yung kanina ang tinitingnan natin is yung amount ng tubig. Ngayon ang titingnan natin sa setting time naman is kung gaano katagal siya mag set initial setting time niya at saka final setting time. So astm C191 standard test method for time of setting of hydraulic cement by Vicat needle. So, itong unang video is for Vicat needle test. Initial setting time is the time period between the time water is added to cement and time at section needle fails to penetrate the cement paste. Placed in the Vicat mold from the bottom of the mold final setting time is the time period between the time water is added to cement and the time at which 1 millimeter needle makes an impression on the paste in the mold, but 5 millimeter attachment does not make any impression on the mold. So, yan ang pagtingin ng initial and final setting time. So, setting time is the time required for stiffening process of cement paste to a defined consistency. So, nasabi ko naman na kanina, initial setting time is yung time mula sa pagkakalagay ng tubig hanggang sa time na plastic pa yung cement natin. After yung initial setting time, kapag di mo pa na-i-place yung cement mo, it can cause a reduction of strength. Tapos yung final setting time naman is yung time na start nang mag-harden yung cement mo. So kapag final setting time na hindi mo pa naaayos yung paglalagyan is yun, reduction of strength possible or cracks, mga ganun yung possible na mangyari. So yun yung importance ng setting time. So let us watch the video for the setting time of cement.
In this video, we will cover setting time of hydraulic cement by Vicat needle. In other words, the time that cement need to react or hydrate completely with water. In order to perform this test, you need the following: the Vicat apparatus, 2 needles, thick and thin one, a mixer, a timer, a 650 gram of cement, and a defined amount of water, which has been determined by the normal consistency test, which we had covered in a previous video. Click here or on the link in the description box to see the video. First, put the cement in the mixing bowl. Then, add the water to the cement. Run your timer at the exact time.
So, ito nga pala, yung amount of water na ilalagay ninyo is yung amount ng water at normal consistency ng cement. Kapag nakuha nyo na yung normal consistency ng cement nyo, yun yung kung gaano karami yung amount ng tubig na yun yung gagamitin nyo rin for setting time of cement. So, hindi kung ano-anong amount ng water yung ilalagay dito. So, unang itetest dapat is normal consistency of cement.
Run your timer at the exact time you have added the water to the cement. You need to prepare the cement paste as we have done in the normal consistency video. Leave your paste for 30 minutes. Place the thin needle on the Vicat apparatus. Set the indicator on 0. Adjust the needle until it becomes in contact with the base surface. Release the needle. The needle will penetrate the paste. Repeat this operation every 15 minutes until a 25 mm or less of penetration is obtained. The time between the initial contact of cement and water and the penetration of 25 mm is the initial time of setting. Then, place the thick needle on the Vicat apparatus. Set the indicator on 0. Adjust the needle until it becomes in contact with the base surface. Release the needle. The needle will penetrate the paste. Repeat this operation every 15 minutes until the needle fails to penetrate the paste. The time between the initial contact of cement and water and the fail of thick needle to penetrate the paste is the final time of setting. And by that, we were able to determine the setting time of hydraulic cement by Vicat needle.
So, yan yung test for setting time of cement by Vicat needle apparatus. Okay, so next we have here the setting time of cement using Gillmore needles. So the initial setting time is the time period between the time water is added to cement and time initial set needle fails to penetrate up to the calibrated mark. So yung initial set needle natin is 1/4 pound yung weight niya. And the final setting time naman is the time period between the time water is added to cement and the time the final set needle fails to penetrate the cement paste. So yung weight naman ng ating final setting time na needle is 1 pound. So para makita natin kung ano yung sinasabi ko dito na needles, tingnan natin yung itsura ng Gillmore needle natin. So ito siya. So kapag hindi na siya mag-penetrate up to the calibrated mark, so dito meron siyang mark dito na makikita natin sa zoom in mamaya sa video. Kapag di na siya mag-penetrate up to that mark is yun yung initial setting time niya between the time na naiyat na yung tubig and hindi na mag-penetrate up to the mark right here. Dito naman sa final setting time, ito naman yung gagamitin na for testing the final setting time. It will be the period of time between yung pagkakalagay nga ng tubig sa sample and the time na mag-penetrate siya up to hindi na siya mag-penetrate up to the calibrated mark. Kasi kapag hindi pa siya mag-set, mas mataas pa sa calibrated mark yung kanyang penetration. So, tingnan natin yung video para makita natin yung sinasabi kong calibrated mark. So, in-off ko yung sound para hindi maano sa YouTube. So, yung amount ng tubig na ginamit dito is yung normal consistency. Same lang din sa pag-test sa Vicat needle. Normal consistency of water dapat. Para pare-pareho. Kasi kapag inulit-ulit mo para pare-pareho, magkakalapit yung magiging time. Hindi magkakaiba yung amount ng tubig na ginamit. Ito yung sinasabi na na calibrated mark. So sa 1/4 pound na needle, hindi dapat mag-touch ito tsaka yung top ng cement paste ninyo. No touch. Ayan. Wait another 15 minutes. So, same sample lang yung ginamit. Ayan. So, yan yung testing of the setting time of cement using Gillmore needle apparatus. So, that would be all for this video. Thank you for listening.